reserves, and also CCS options that could be integrated with the hydrogen production. So both of the renewable and CCS hydrogen can be produced. There is also a prospect for natural hydrogen in Australia as well. It has been some recent discoveries in South Australia that is showing very high concentration of hydrogen in the gas samples that is taken from underground. We have abundant water, land, renewable energy, and fossil fuels that enables the diverse production technologies. Underground storage is also another possibility that offers flexibility and seasonal storage. Australia's geography also provides unique opportunities for hydrogen production and grid support. So now let's look at the Australian hydrogen market. Australia is well placed for renewable energy export and also manufacturing. So as you can see in the left-hand side graph, until 2030, the target is mostly for producing hydrogen for the domestic use. But as we go from 2030 to 2050, you can see that the export option also ramps up. Hydrogen can be used as a chemical or as a heat input to the production of green metals, ammonia, and also low carbon liquid fuels. Hydrogen in Australia mostly plays a very important role in decarbonizing hard-to-abate sectors such as long-haul transport and aviation, and also, as mentioned, for production of iron and steel and also aluminum. It would also potentially support the power generation as well. So we have some challenges to deploy a clean hydrogen economy. Producing low-cost hydrogen at the scale is a challenge, and I think it's not only unique to Australia, but many other countries are facing the same issue. There is still a very large gap between the projected demand and supply growth rate. We need diverse sources of hydrogen to help the countries achieve their net zero ambitions at least cost as well. And as we are all aware, the larger scale hydrogen projects require substantial upfront investment, which is not only for the energy infrastructure, but also for the non-energy infrastructure as well. We need a huge investment in the bulk storage of hydrogen, a distribution system for hydrogen into both the domestic and export market. We need a strong safety systems and regulations, and also a policy, favorable policy. Again, growing hydrogen industry needs a skilled workforce as well. So now I just would like to bring your attention to the Australia's 2024 National Hydrogen Strategy, which has 4 objectives. In the supply side, the most of the effort is for helping the hydrogen production, which is currently very expensive. Australian government supports the industry through incentives and programs such as hydrogen production tax incentive, Hydrogen Head Start, a Future Made in Australia Innovation Fund, and also Australian government is supporting the hydrogen hubs across Australia as well. In the demand and decarbonisation, we have mostly identifying and supporting the most prospective hydrogen demand sectors, which is mostly green metals, including iron and alumina, ammonia, long-haul transport, including heavy road, aviation and shipping, power generation and grid support, and they are all backed up with safeguard mechanism. Safeguard mechanism is Australian government policy that set limits on the greenhouse gas emission from large industrial facilities to encourage them for the uptaking of hydrogen. In the community benefit, we have to make sure that the communities are aware of and also realize the benefits of hydrogen, expanding the First Nation Renewable Hydrogen Engagement Fund pilot, establishing a national net zero economy authority, and plan for the water demand that is needed for the hydrogen production in the New Water Initiative is some of the activities that Australian government is actively pursuing. In the trade, investment and partnership, setting a target, export target, for example, for 2030, Australian government has set a target of 0.2 million tons per year of hydrogen, and with potential to increase to 1.2 million tons per year of hydrogen as well. Austrade and Net Zero Economy Authority will attract international investment in Australia. Guarantee of Origin is a verification and certification scheme, which is verifying the hydrogen emission intensity of the hydrogen produced in Australia in the international market. International partnership will foster the knowledge sharing, research development and demonstration, and supply chain development as well. So Australia's government invests in the research to commercialization pipeline as well. By providing funding for supporting research development and early stage commercialization through co-investment, CSIRO as Australia's national science agency plays a very important role in collaboration with universities, research institutes, and also industries to develop technologies and supporting the commercial uptake. So CSIRO is involved in early stage R&D up to the deployment and commercialization of the technology. We have some focus areas in this topic, which include clean hydrogen, energy storage, industrial decarbonization, and also agricultural emission reduction. CSIRO also has established a mission-driven multidisciplinary science and research program for partnership with international markets and also with industries. We have, for example, Hydrogen Mission that is actively working in this area. Some of the other CSIRO's hydrogen initiatives, so CSIRO has been actively engaged in developing reports and roadmaps for hydrogen in Australia. We have developed a national hydrogen roadmap in 2019. It was published by CSIRO. We also have hydrogen research, development and demonstration, which is setting the priorities and opportunities for Australia in the hydrogen demand. Hydrogen vehicle refueling and infrastructure is also another report that was published by CSIRO. So these are some of the reports that I mentioned. We also have a R&D portal, which is basically the database of various projects that are ongoing in Australia. So High Resource is a list of all of the projects that are mostly being done in the demonstration and commercialization scale across Australia with the information about them. High Research is Australian Hydrogen R&D portal. So all of the projects in R&D that is related to the hydrogen is listed in this portal. And High Learning also providing information about hydrogen. It has some data visualization tools as well. These High Research and High Learning will facilitate the connections and collaboration, not domestically but also internationally as well. And it will assist in identifying the knowledge gap and also supporting the future R&D program development actions. So this is my last slide. I'm going to talk about some of the hydrogen and ammonia research portfolio and the activities that we are doing at CSIRO. It is not all of them. I try to summarize most of them. In the hydrogen production, we are working on developing novel hydrogen production. We are working on natural hydrogen, photocatalysis, developing novel electrolysis technologies for decreasing the cost, and also decreasing the amount of the critical minerals that are needed in the electrolyzer technology. We are also working on ammonia production. We work on low pressure synthesis of ammonia, electrochemical synthesis of ammonia, and biological synthesis as well. In the hydrogen storage and distribution, we work on novel hydrogen storage options. We have a look at geological storage, hydrogen liquefaction, and ammonia and liquid organic hydrogen conversions. In the hydrogen handling, we're also very much active, working on metal hydride compressors, hydrogen embrittlement, and handling of materials that are in contact with hydrogen. In the utilization of hydrogen and ammonia, we work on using hydrogen in fuel cells, using hydrogen in industry and also hydrogen burners, and in the ammonia we're working on solid oxide fuel cell ammonia, ammonia cracking, and ammonia engines as well. And all of these research and development are backed up with cross-cutting value chain project, which is mostly for doing LCA, techno-economic assessment, social license, and regulatory requirements. That's all from me. Thank you very much for listening.
Thank you, Tara. Your timing was perfect. Thank you for a great overview of what CSIRO is doing to be able to support the hydrogen technology development in Australia. The last presentation is mine, which is the last presentation before the coffee break is mine, which is performance demonstration and analytical support. Sorry, let me start my timer to make sure I'm on time. I'm not just trying to keep everybody else on time here. So let me get this started. All right. And I'm going to focus on what NREL is doing, and NREL is doing a lot of different things across the hydrogen economy. So I'm just going to focus on a few different areas that we are doing some support in terms of demonstrations and analysis, and then finally some safety and codes and standards to be able to support the commercialization of hydrogen within the United States as a whole. As we've already talked about, many nations have roadmaps. This is pulled from the US's roadmap and really thinking about when might different technologies appear on the left side in terms of the short term, medium term, and long term, and what the size of the different technologies might be on the right side. So really focusing in the near term on some of the current hydrogen uses like ammonia and refining for green hydrogen in the 2030 timeframe, and then growing from there into green metals, into energy storage for the grid, and into long distance trucking and other types of areas as a whole. Here we go. So one of the things that we're doing is we've got this Advanced Research for Integrated Energy Systems, or ARES site, that we use for demonstration. And we heard a little bit from AIST about their demonstrations being able to look at round trip hydrogen production, to be able to then feed back to the grid. We're doing something very similar at NREL in terms of a 1.25 megawatt PEM electrolyzer to be able to produce hydrogen from what we consider to be excess electricity, looking at opportunities with to be able to follow wind and solar generation and others, and then moving into a compressor and underground storage, and then a fuel cell to circle it back to the grid as a whole, to be able to think about, be able to look at and think about what the round trip opportunities might be, and be able to demonstrate them at scale to be able to reduce the technology risk into the future. A second area that we're doing demonstrations in is heavy duty fueling, especially to be able to support standards development. So we've got a wireless vehicle to dispenser communication for heavy duty fueling that we worked with multiple OEMs or vehicle production and technology development groups to be able to demonstrate how we might be able to fuel heavy duty vehicles, which require relatively large amounts of fuel. So 73 kilograms of fueling in 6 minutes of fueling time plus a minute for the truck to pull up and pull out, and to be able to then do the simulation and be able to prove that that fueling can be met. This is how to do it safely. This is how to manage the temperature issues. This is how to manage some of the storage and embrittlement issues and other issues such as that. That's two of the demonstration areas. There's a lot of other demonstrations going on, from very small scale demonstrations looking at technology development to larger scale ones. I wanted to point out those two. Moving into more of the analysis area, there's a lot of network analysis that we're doing, and I think there's some opportunities for collaboration across the different organizations in the RD20, thinking about network analysis. So we use the SARA model, or the Scenario Evaluation and Regionalization Analysis model, to be able to simulate how hydrogen infrastructure and supply systems might be able to meet, especially for urban fuel cell electric vehicle markets. So that includes data all the way from energy resources and where that energy might come from, where the hydrogen might be produced. You can see some locations in the second figure here, to storage and delivery mechanisms that would be needed, like long distance transport, to be able to get the energy to their locations, and then retail station networks to meet fueling needs as those fueling needs advance for heavy duty vehicles and other vehicles as a whole. And using a tool to be able to think about what that is, what those requirements are. We talked a lot this morning about kind of that problem of making sure that there's systems available when the vehicles might appear, and the supply and demand timing type issues, and be able to support some of that and optimize some of those pieces. A second area where we're doing a lot of analysis is site opportunities. So in the past, we really thought about the TEA workforce, which we'll talk about on Thursday, is really thinking about how to produce hydrogen at a single site and what that looks like. Another opportunity is thinking about what the demands might be. One example is airports, which NREL is doing a lot of work on to be able to think through the infrastructure requirements and the scheduling type issues to be able to fuel, if not the airplanes, at least the ground source equipment and the APUs or the power generation for the airplanes when they're sitting on the ground, and any of those, to really think about what are those needs, how is hydrogen able to fulfill those needs, what are those costs, what are some of those opportunities. So that might be another area where collaboration makes sense across the RD20. A third area that we've heard in several different talks this morning is around supply chain analysis. This figure is based on some work that NREL and the U.S. Department of Energy have done, thinking about what different materials are. So on the x-axis, you can see the different types of material availability. What does the domestic supply chain look like? Where is it available? What's the diversity of availability? Whether there is workforce availability in terms of construction and operations talent, and those, and then down the rows are more focused on different technologies, whether those are hydrogen production technologies, mostly electrolysis, midstream technologies like pipelines and compressors and liquefiers and storage, and then utilization in terms of refueling stations. The yellow and red are ones that have been identified as ones where there are challenges as a whole and might need to be filled. So as you can see, there's a couple of them in terms of supply chain needs, in terms of the electrolyzers, and then in terms of availability of global equipment, really gets into some of the yellow space for the downstream equipment, whether that's liquefiers or refueling stations or some of those. My final slide is really focused on hydrogen safety and sensors and some of those technologies. I see this as another opportunity that these RD20 institutes can work together to be able to address sensor and safety and some of those needs. So what we get into here at NREL is safety and process control and sensor testing, developing technologies such as wide area and standoff detection technologies as a whole, and then really thinking about some of the simulations for insurance and for other protection type things to be able to do risk reduction and to be able to pay for risk reduction strategies as a whole. This involves everything from sensors and sensor tools to emission detection, to quantification, to component reliability, research and development, and some of those areas. So those are areas where we really think that there are potential opportunities for the RD20 institutes to be able to interact and to be able to do more work together, that there might be other opportunities for us as a whole. With that, I'll close with just a quick reminder in terms of some of these potential opportunities for collaboration. So this isn't the whole set, but is a set of ones that NREL has and we're really thinking about might be good areas for collaboration in the future. The first one is demonstration of round-trip energy storage systems and thinking about electrolysis connected to storage, connected to fuel cells, connected to grid needs and demands. And a second demonstration one, which is really focused on heavy-duty fueling stations and the codes and standards necessary for those. In the analysis space, there's 3 of them that I identified, kind of network analysis, how we might build out what that chicken and egg, what the hydrogen network might need to be, what the site opportunities might need to be, especially on the demand side, and what some of the supply chain limitations and opportunities might be. And then finally, thinking about codes and standards and where the RD20 institutes might be able to coordinate, thinking through sensors and safety and what some of those opportunities might be. And of course, there's many, many others that we will talk about after the coffee break this morning, after we got a few more presentations from other nations and the coffee break this morning. With that, I'll close with my presentation and turn it over to